1, we are going to look at changes in slope. So this is the second video in our lesson. This is reflecting just the number for slope, not talking about it in terms of a positive or a negative value. So we're just looking at the number, the m, and not looking at its positive or negative sign. So we're going to compare y equals x versus y equals 2x and look at how the changes in slope sort of happen. Y equals x, if I were to write that, y equals 1x. If I were to graph this, FYI, I didn't say this in the last video, I'm always comparing this to this function. You may end up seeing functions where the parent function that we're using is a different setup than y equals x. It might be y equals 2x plus 4 versus y equals 2x, and we have to describe what happened and it's changed. This particular function, I'm always going to compare it to this. I'm going to call this the parent function. Because this is what we're sort of basing all the differences on. If we think about parents versus children, we know two parents make one child. And so because of that, we are looking at one parent function and then looking at its children and saying, how has it changed based on maybe the other parent being involved or whatever else. So like if I look at my son, he has blonde hair like I did as a child, but he's definitely a lot skinnier than I was, and he takes after his dad in that case. So, or at least as a child. My husband's not necessarily skinny now, but he was when he was a kid. Parent function. So we have this parent function of y equals 1x. We're going through 0, 0. It has a slope of 1. So I'm going to now show my slope of rise over run of 1 over 1 and continue it down in the opposite direction and finish this baby up by connecting the dots. So that is my parent function that I'm going to compare this function to. We have this function y equals 2x. This function also goes through 0, 0 because the y-intercept essentially is plus 0. But my slope is 2, or 2 over 1 if I were to write it out. So 2 over 1 means I'm rising up to 2 and going over to the right one, rising up 2, going to the right one, and so on. And I'm creating this line that is slightly steeper. And if I look at my original line versus this line, this second line has become steeper. It has rotated counterclockwise. So we can talk about changes in slope, and if our slope has increased, if the number has become greater than its original number, we will see a counterclockwise rotation in that line. If we have a number where it goes smaller, I think we can now predict what would happen. So again, we have the same parent function, so I'm going to just quickly draw this graph because I know what it's going to look like based on the one that I just drew. There's my original graph. That's our parent function. And now we have this function, y is equal to 1/3 x. So we already have the rise of 1 and a run of 3. That's kind of nice. I'm going through 0, 0. My y-intercept is 0. And so now I'm going to graph this. Rise of 1 over 3. Rise of 1 over 3. Rise of 1 over 3. Same thing in the other direction. 1, 2, 3. And I can now finish this graph up. And I can see I still have a puff positive slope because we haven't changed what's called the polarity, which we talked about in the last video. But we can see that it's rotated this time clockwise. So this particular line has gone from this nice 1-1 slope, or this very proportional slope. I mean, this is still a proportional slope, but it has rotated it to become a bit shallower. So we have one more video for this set of lessons, and we're going to be talking about y-intercepts and how those change. And then after that, you will be able to practice with the must-do practice problems and take the exit pass. Thanks for watching.